So good afternoon, everyone, and it's great to see that the rain has kind of been a little bit kind now. So long time back, I watched a movie. It was called Lactose. It was made by a French person, but it starts off in India, and it tracks the music and dance from India all the way, and it traverses through Europe and so on. I think yesterday when I was watching the Bulgarian dance and the attire, I kind of felt that there was some similarity between India and Bulgaria. And I think, sure enough, when I was reading up on some of the material that's out there, there is some parts of India that traverse through Central Asia, and I think that's the connection. So hopefully we'll find a little bit more. But today what I'm going to talk about is, I've been in genomics for about 20 years, ran a company which worked with a lot of the large pharmaceutical companies. We sold them databases that were used for early discovery. One of the biggest challenges in most of these databases was that it was very Caucasian. And the world is not truly completely Caucasian. And I think as we move towards precision medicine, we need to have representations from all over the world. And my motivation, the fact that Indian population is about 20% of the world, but only about 0.2% of the data generated, I think motivated me to start something in the consumer and clinical genomics space. So very different approach than working with pharmaceutical companies on a specific project, because now we are going out there directly to consumers, trying to convince them that it would be a good idea for them to take a DNA test. I think in most cases, I think understanding what a DNA test was the first challenge, because it's not something that is very, very common. But as you can see over here on this slide, you'll see that there's been a lot of bias, and I mentioned that only 0.2% of the data is that of the Indian population. I think you can look at the number of studies that have been done worldwide. So of 2,500 odd studies, I think you find that where 35 million samples were looked at in the GWAS catalog, there are very small population of that was even from the populations outside of the Caucasian population. We also found that when you are looking at drugs for specific individuals, it depends on the pharmacogenomics, so understanding that for different populations is important. 23% of the published studies were focused on oncology, 14.7% on psychological disorders, and so on. So you can see that even in diseases, there are some biases that are there on specific areas and not on everything else. So I think as data becomes more the currency of healthcare, what we want to do is to be able to say that we want to create meaningful, deep data from consumers where they consent, but to be able to use that, sorry, my mic is going back and forth, but to be able to use that to actually find solutions for the healthcare industry. So what I thought would be useful is that, Indians have a very large number of diseases, including examples of diabetes and cardiovascular. But we also have the fact that when you look at breast cancer, we have specific mutations. We have the triple-negative cancer, and so there are very different incidences of diseases in India, but a lot of different kinds of diseases. So it's a great place to be able to collect data on different targeted segments. We also see that only about 50% of the drugs are properly advised. This is not a great mic. I'm going to hold it like this. So I think these are just some examples of some studies that are there. And I think that's probably a good idea. Yes.
Can you just turn this one on for her? Is that okay? Is it on? Yes? Good. Sorry about that.
It's just going back and forth.
Yeah, don't worry. We'll just get it over. Thank you very much.
Thank you. So I thought I'll spend most of my time trying to give some examples of the kind of things that you can do when it comes to actually what value it has for consumers as well as physicians. So I think when you look at most of what is happening, I think just as an example, how many of you have actually done a genetic test? Just 1, 2, 3. Is it mostly for ancestry purposes, or have you actually done it for a health purpose? Only 1, 2. So not many people, but you can see that there are a lot of genetic testing options available worldwide. But I think the fact is that when you look at what is happening, you want to be able to make sure that it's not just about understanding what your markers are going to tell you, but it's actually to be able to take actionable steps, whether it's clinically relevant steps like what kind of drug is likely to work for you, but also what kind of health risks are there, but you have to correlate that with your family history and clinical history and so on. So these are examples of the kind of studies that we have seen in the Indian population that we find that there are differences that are there. And these are examples of what we found in our database currently. So in the database that we have, we found that we had a greater frequency of G6PD mutations in our database, which was probably because consanguinity is one of the factors. That means the parents were related, and therefore you found that a lot more mutations of G6PD were there. We also found, very interestingly, among the fitness category, that when you look at the sports, the endurance versus the sprint muscle, we found that about 50% of them belong to the heterozygous or the mixed category. We don't have enough of the sprint kind of category within India. And you find a lot more in Africa and other places. And I think that's partly how human migration actually worked out. We also found that there was a very different spectrum of CYP2D6, that's a no function or a reduced function allele in Indians versus Caucasians. So you can see that there are differences. The last one more point that we found was that of lactose intolerance. Now, Indians are very fond of drinking milk and milk products, but we found that there was a very high percentage of lactose intolerance in our database, and it potentially could be that it's true that is there, but it could also be that there are other markers that we haven't yet found. The other thing that is obviously the most interesting thing is that of pharmacogenomics, whether a certain drug is likely to work for you or not, whether you metabolize the drug very rapidly, or you don't metabolize it at all, or whether it's going to produce toxic effects for you. So what we did was, you can see that on this slide, you can see that all the red people in that are people who don't actually respond well to medicines. But we all get the same kind of drugs. So when you go to a doctor, you get medicines, and you find that 75% of cancer drugs don't actually work if you didn't actually do a genetic test for them. Similarly, I think there are many others that are there. So the FDA today has about 150 drugs that they have recommended or required genetic testing for. And I think this will only increase because if you see the kind of drugs that they are also approving, they are also now based on these markers. So this is what we do. We collect family history, medical history, as well as genetic information. And very interestingly, we created 3 products for the consumers. And I think we called the first one as Genome Patri. For anybody who understands Hindi or is Indian would know that Janam Patri, which is a play on words, essentially means that you are creating a horoscope. And we did that because it was easier for us to be able to connect with the average Indian consumer. But we also realized that it's not just enough to do just a preventive or a predictive kind of a test, because in many cases, there might be people who need a deeper dive. So you might need to do like a whole genome or a whole exome sequencing. So this is what we do. I think we, like most other genetic testing companies, we have a little swab that comes in a box as people order it online. And once they get it, I think the difference between the kind of products that you get, like an Ancestry or otherwise, is the fact that you get a lot of health information. And in this health information, you also get counseling, genetic counseling that helps you to understand what that report actually means. Because in the end, I think for most people, they really can't interpret what that report means and what they need to do. So this is the kind of things that we cover. We look at a lot of different health risks. Some of them are lifestyle related. Some are respiratory. We look at pharmacogenomics and so on. So this is the kind of examples that you get, right? You look at different kinds of traits. Are you likely to respond well to coffee, all the fun stuff, the traits, or even things like risks for your blood pressure and things like that. Then there is disease risk estimation. Are you at risk for diabetes versus the others? Whether you are a carrier for a certain condition. And finally, I think what kind of a drug response you have. And I'm going to show you a few examples over there. So this is the report that looks like, and it shows in a fairly simple way whether if it's green, yellow, and red, like most people, we'll give a nice chart. But then we take it to the next level, because we are taking actually information that comes through your clinical history and family history. And this is an example of a pharmacogenomics report, right? So if you look at that, there'll be statins, clopidogrel, and many other such drugs. And it'll tell you whether that's likely to work for you, whether it's efficacious, whether it's likely to be toxic, and so on. And this is what you get after you've had a counseling. So you have a genetic counseling, and then you're given recommendations, what kind of dietary modifications, whether there are additional screening tests needed, and so on. So this is what you get after that. Now, when you look at some examples that we have, and I'm going to just quickly go through that. These are a few examples that we have. Now, this is an example of a 22-year-old male. He was a hardcore fitness enthusiast, had a passion for running, but suffered from 2 ankle injuries. So he came to us to see if there was anything that he can do in terms of nutrition or wellness. So we found that he had a high genetic risk for antioxidant deficiency. So we gave him some recommendations in terms of what kind of exercise is likely to work for him, what kind of supplements are going to work for him, and so on. This is another example of someone who didn't have any major health issues, but essentially came to us and said that all of a sudden found out fatigue-related issues. So we found elevated genetic risk for B12, B vitamin metabolism, and we also found a reduced folate levels. We found that she needed a very specific supplement for that. One more example is that of a 25-year-old female who had personal history of obesity in adolescence, underwent significant weight loss, and after she switched to a keto diet, which I think a lot of people do, we found that there was significant weight gain. So we found that her sensitivity to dietary fat was likely to gain weight. So I think we saw that. We gave her a certain restriction in terms of what kind of food is good for her, and then she was able to actually lose that weight she wanted to. This is another example of a 28-year-old male with a personal history of allergies and gout. I'm looking at the time. And we found that, we can go on, okay. He felt discomfort in his legs, so we suspected restless leg syndrome, right? So we found that he had an elevated risk for restless leg syndrome, and he was then consulted about that. There's another example, and I'm taking only examples of people who are fit and who are healthy, not taking the cases where we actually get people who come with a specific problem from a hospital or come through a genetic counseling session. Again, this is a 37-year-old female who's a mother to a healthy 3-year-old child, right? So a child doesn't have any problem. We found a personal history of asthma, allergic rhinitis, dyspepsia, contact dermatitis, stress, and depression. We found that she was positive for G6PD mutations that made her a carrier. Similarly, there was another 32-year-old male, personal history of B12 deficiency, had consanguineous parents. We found that he had elevated risk for male pattern baldness, and I think he was very worried about premature baldness. So I think, which is very strange, because one of the things we found when we asked a lot of our customers was, what are you really worried about? And they said baldness, which was a strange thing, but I guess it is important for some. Again, here we have a 52-year-old female with a personal history of hypothyroidism, borderline LDL, and had factor V Leiden, a lot of family history of that. And we found that she was actually homozygous for factor V Leiden, right? and was then given specific recommendations. Now, I'm not going through all the details of all these cases, but you can see that in some cases, we've also found that people come to us with no problems at all. We find a particular mutation in their, in their genetic report, and we actually have then gone in and found that they actually have a mutation that needs actual real medical intervention at that point. This is an example of that. So he had only hypertension, came to us, and we did a preventive test for him. We found a certain deletion in a particular gene, and we said that you need to go and do a confirmation of this particular gene. So we did find that he had a mutation that did correspond to hypertrophic cardiomyopathy, which is a dangerous condition. So we made sure that he was given information about what to do with that particular, the meaning of that particular confirmation or diagnosis, and then he was able to then go to the next steps of what is required with his physician. Again, I think, so I have a lot of different examples of this kind, but basically what I want to, sum up with is that when you look at genomics and you look at what you can actually get out of it, I think what matters is that there are 2-3 types of things you can do. One is to be able to say, if I want to understand if a certain drug is likely to work for me or not, is this going to give me valid information? Second is, if you're trying to understand if you're at risk for something, is that going to give me that information? Now, there are many types of genetic testing. So what you need to know, and when someone is trying to understand a genetic test, is to understand whether they're doing it for diagnostic purpose, or they're doing it for just a preventive or predictive value of a so different things, but sometimes one may lead to the other. So I think I don't want to go into many, but I'd be happy to share any of these cases or anything else that you might likely to have over there. So these are many other such examples of pharmacogenomics in terms of what happened with patients that switched to different medicines and how we were able to help them and their physicians. So I think with that, if there's anything that you're concerned with about genomics, any questions, I'm happy to answer.